Hey kids, Math here. We got AP Classroom, FRQ, excuse me. We have D&S Classroom. D&S Chapter 4 FRQ solution video here. This one is going to fall into more bonding, more IMFs. Boy, it seems like every worksheet we're doing, there's a lot of bonding and a lot of IMFs. But when you think about it, this test is going to have a lot of bonding and IMFs. It shouldn't have a lot of stoichiometry. That's stuff you could look up. Gas laws, we've talked about that a fair amount lately. And then the other third major topic is going to be kinetics and equilibrium. That's coming up a little later on in some of the higher number ones. So let's get on with it and get this one solved. These are pretty straightforward questions. Draw a Lewis structure for CH4. Say, all right, can do, killing it. CH4 shape tetrahedral. How about SF4? Well, now we got to take everything else that's the same, put that S in the middle, go, okay, we're going to go 1, 2, 3, 4, put those F's out there. This is a very covalent bond. Don't worry, it is not ionic. Put that there. 4 and 1, that's a seesaw. There we go. Draw the Lewis structures, state the shape. Done. How about B? It says state two factors that account for that. Your factors are very similar. Basically, factor number 1 is going to be polarity. And polarity from the standpoint that CH4 is nonpolar, and therefore LDFs, which are a weak IMF, so it has a very low boiling point, whereas SF4 is going to be very polar, therefore dipole-dipole, strong IMF, and a higher boiling point. We've seen that answer over and over and over again. Then in C, we finally get a new question. Hey, which one's going to be more soluble in CCl4? And, oh, wait, that's only one. I'm sorry, you need the second answer. The second answer is going to be LDFs, that even though they have them, SF4 has more electrons, therefore higher LDF and a higher boiling point. Those two things are different. One is the permanent polarity of the molecule, and the second one is the temporary or momentary polarity of the molecule. So don't get those two confused. Okay, now we can answer C. And C is going to be which compounds more. Now we get a like dissolves like, and we say something along the lines of CCl4 is nonpolar, like dissolves like. Yep, you can just say that. So CH4 will be more soluble. Okay, pretty straightforward question. A little bit IMF, a little bit of dipole-dipole, LDF, and then a little bit of like dissolves like. How about 2? 2, we start getting into some real similar stuff. It wants us to compare vapor pressures, and we're going to see that again in question number 3, or question number 4, excuse me. Vapor pressures. Why is H2O have a lower vapor pressure? And this one's real simple. It's both of these are hydrogen bonding, but H2O has more hydrogen bonds. So it has more intermolecular forces. The molecules are interacting more because hydrogen bonding is happening on both ends of the molecule, whereas in CH3OH, the hydrogen bond is only happening on one side of the molecule. So it has more IMFs, which leads to lower vapor pressure. See, the train of thought is still the same. Stronger IMFs, lower vapor pressure, all real straightforward stuff. In B, they want to talk about I2 versus CL2. This is very similar to another problem I feel like we did back in 1, where indeed the I2 has more electrons. Watch me sneak this one in. More polarizable than Cl2, and therefore higher melting point. And then I realized C is the exact same question, same as chapter 2, question 1. You guys can go back and look at that, but you know this about silver, molten silver and versus non-molten, and the same with the AgNO3. And D was the same thing. Chapter 2, question 1. Not going to answer it. Again, you guys have already heard the answer and know the answer. Let's get on to something different, something new. 3 was new. It said diamond's really hard and it can be used as a cutting tool. Graphite is not. How come? And explain this in terms of chemical bonding. So what we say is carbon as a diamond, that is very unique. It is what's called a network solid, and network solids are held together with what we call directional covalent bonds. That's going to make this a very strong three-dimensional model. Whereas graphite, not so much. Graphite is soft. Graphite is a two-dimensional solid where layers of atoms can slide. It's very soft. So not much going on in A. What about in B? In B it says sucrose doesn't conduct electricity, but potassium nitrate does. And so what we say is C12H22O11 dissolves, whereas KNO3 dissociates into ions. No ions need either. There are two ways to get a conduction, and we've heard this over and over again. You either get a conduction from free electrons, such as in metals, or free ions like KNO3. That would be a nice answer. Now let's look at 4. 4 brings us now, for the first time, we're talking about vapor pressure and gases in IMFs, and we kind of like that. So in 4 it says, under what conditions, so they've given us 5 things here, and they're saying at 10 degrees Celsius, which of these would observe to be boiling? Because at 10 degrees Celsius, the pressure in each flask is 50 millimeters. So we're going to need an explain. And so they ask us about which would be boiling. I would use this opportunity to say that boiling occurs when the pressure of the gas is greater than or equal to the pressure of the total atmosphere. And so in this case, where the pressure of that atmosphere is 50 millimeters of mercury, the only one that's greater at 10 degrees is the CCI4. That would be the only thing that's greater than. And I don't need much more of an explanation with that because we've described what boiling is. Boiling is when, and CCI4 is the only one, only species above 50 millimeters of mercury. Then they say, hey, let's raise the temperature up to 25. Well, now at 25 degrees, now all of a sudden, we've got 1, 2, 3. And obviously, if something boils at 10, it's also going to continue to boil at any temperature above that. And so, which liquids? And it would be the same sort of answer where we would say ethyl alcohol, CCI4, and benzene all have vapor pressure greater than 50 millimeters of mercury. Therefore, all 3 will boil. Boom. That's all you need. So we had a really neat question set here, one that involved gases, one that involved liquids, one that compared some LDF, some H bonds, a little bit of everything. Once again, a lot of IMF review. I know you're getting a little bit worn on it, so am I. Let's hang in there. I'm Smath. I hope this video helped you.